How large is the Earth? Obviously we cannot determine the dimensions of the Earth by measuring it directly, but there are several indirect approaches. The most renowned historical method, by 3rd century BC astronomer and mathematician Eratosthenes of Cyrene, involves observing rays of sunlight penetrating well shafts in different locations. We shall follow instead a scheme devised by the great scholar Abu al-Rayhan, Muhammad ibn Ahmed al-Biruni, AD 973 to 1050. One of the most prolific authors of the medieval period, Al-Biruni wrote at least 146 treatises on almost every area of science known in his time, including mechanics, medicine, and mineralogy in addition to mathematics and astronomy. One of his most famous works describes social and religious practices, geography, and philosophy in India. His Kitab Tawhid al-Makin is a book on the determination of the coordinates of cities, was inspired originally by the problem of finding the Qibla, the direction of Mecca, toward which Muslims must face to pray. Since it's just as easy to find the direction to some location other than Mecca, the book is actually a comprehensive description of mathematical techniques of locating cities on the Earth's surface. Al-Biruni begins by determining the height of a nearby mountain, near Nandana, in northern Pakistan. This isn't as easy as it sounds, since the point at the mountain's base is buried under tons of rock. He builds a square. Since he does not tell us how big it was, we set the square's side length equal to 1 meter for the sake of convenience. He then lines up the square so that the sight line along it to shade out top of the mountain. Let H be the perpendicular projection of D onto the ground, and let T be the intersection of AB with DE. Using our meter stick we measured GH equals 5.028 centimeters and AT equals 0.01648 centimeters. Clearly, it's impossible to measure such a short distance with such accuracy. The fact that Al-Biruni was able to get a reasonable value for the Earth's size suggests that his square must have been huge. Now we use similar triangles. From GEGD equals ADAT we compute GE, and from EZG equals GHDG we find the mountain's height to be EZ equals 305.1 meters. Not exactly a colossus, which is just as well, since our next task is to climb it. Once we have reached the top of the mountain, we look to the horizon. With good enough instruments we should notice that the horizon is not precisely horizontal to us, but dips slightly downward. Al-Biruni tells us that he measured the value theta for this angle, which is very small, but likely just within his capacity to measure. We know that theta is also T, O, Z, at the center of the Earth, since the triangle O, T, E, is a right triangle. But we know theta. So the left side of the equation is cosine, 0.56667 degrees, and the only unknown on the right side is r. Solving for r, we find that the Earth's radius is 6,238 kilometers. There is a delicate matter hidden in this solution. However, a minute change in the value for theta results in a large change in the value of r. One wonders how Al-Biruni pulled off the accuracy that he did. Multiplying by 2 pi, we get the value for the Earth's circumference of 39,194 kilometers. Its actual value is about 40,000 kilometers. Not bad, in fact, maybe a little too good for a process with its share of crude measurements.